students, in the present video we'll discuss about storage automation and virtualization concepts. So first we'll take policy-based storage management. Policy-based storage management consisting of all kind of IT resources including applications, computer platforms, networks and storage. So the policy-based management, which includes all kind of applications which are running on the platform, as well as the computer platform, network and the storage. Policy management is necessary for aligning underlying technology to the business requirement. So why we are going for policy management? Policy management is necessary in order to build the underlying technology as per the business requirements. The SNIA, the Storage Management Interface specification, establishes a common management structure for heterogeneous SAN. So the set of policies will be framed under SMIS, which establishes some sort of common management structure for heterogeneous SANs. The Common Information Model defines management objects for a wide diversity of network and compute resources. So we can also have a single model. So that is nothing but the Common Information Model, which defines some set of management objectives for a wide diversity of network and compute resources. The Common Information Model objects are managed through a web-based enterprise management protocol. The Common Interface Management Schema includes policy classes for automating IT processes. The CIM provides a storage configuration service model for creating and manipulating virtualized resources. So the CIM, which also provides the manipulation of some set of services which can be configured from the storage side so that it can manipulate the virtualized resources. The storage services and policy objects may be combined to provide automated storage virtualization. So we can also have automated storage virtualization by combining, we can also have automated storage virtualization by combining the policy objects so that it can provide automated storage virtualization. The policy management is based on hierarchy of policies that span from upper layer interfaces to underlying physical resources. The policy management, so it is depending upon or based upon the hierarchies of policies from the upper layer to the underlying physical resources. The policy-based management transforms the physical SAN into a collection of services supporting businesses' applications requirement. So these set of policies were exactly framed with respect to the IT standard, so which transforms the physical SAN into collection of service supporting business application requirements. So here we can observe that the policy-based management is predicted on a hierarchy of policy objects that governs different aspects of virtualized interface. The services under policy enforcement must be coordinated to accomplish the overall policy goal. So we can set the policy from with respect to the policy management. So we can set the different policies can be considered from the topmost layer to the physical resources, and those set of policies can be combined in order to achieve the set in order to achieve the overall policy goal. So this is just example for homogeneous management of a heterogeneous SAN via CIM is provided by the vendor supplied CIM provider in all SAN components. Abstracting vendor capabilities into uniform vendor neutral features, which enables the fabrics and storage as assets to be treated as a single entity. So with respect to the CIM, across the consumer side as well as the service provider side, which will segregate all the policies, and it will treat the entire platform as a single entity, but whose behavior is determined by the higher level business requirement. So here we can observe that we are having some fabrics, and fabric manipulation can be considered by considering the zoning, pathing or security concepts, and we'll be having the virtualized appliances also with the mirroring, replication, snapshot, backup or life cycle management, and there will be CIM provider along with the CIM provider. The CIM provider they'll check the policies which is framed under this, as well as they'll check the policies with respect to the consumers. So by combining that, they'll consider or they'll treat as a single entity whose behavior is determined by higher level business requirement. So while setting the policy, so we have to check high level requirement of any business. So among those set of applications, I have to check what exactly the higher level of requirement which is requested by the business need. So depending upon that, we can have a single entity, but behavior is determined by considering higher level business requirement. So here we can observe that application-aware utilization or virtualization, which requires identification of the upper layer application based on a data characteristics and enforcement of a policy hierarchy to apply the appropriate storage service over time. So here we have to check the first thing is we have to identify the application data type. What exactly the application data type? So depending upon that, set the policy. How the data can be exchanged, set the policy. What kind of database can be used, set the policy. Either the application is video, set the policy. Underlying software or physical resources, so that means the default policy. So depending upon that, we can have different policies like lifecycle management policies, data protection policies in order to secure the data, capacity policies in order to expand the storage capacity, class of storage policies, as well as fabric pathing policies while exchanging the data. So these can be automated together, and we can have a single entity, so that the entire entity will be having the policies for different levels. I can say that policy A, policy B, policy C, policy D, and default policy for physical interface. Policy-based management provides a foundation for tighter integration of applications and storage virtualization. An application-aware virtualization entity must identify specific application data types and launch the appropriate policies for data handling. So here, application-aware virtualization entity. The virtualization entity, it will set a specific application for different data types, and it may launch some set of policies for data handling. So in order to in the topmost level, we can have the some set of what we can say that virtualization entities will be there. So those entities will identify the specific application data types. Depending upon that, they can launch the respective policies for data handling. Application-aware virtualization must respond to changing application needs. So whatever the application aware utilization entity, so that must respond to changing the application needs, such as capacity requirement and life cycle management. While speed frame analysis is required to maintain storage performance levels. So the diagram shows virtualization aware policies. So we can observe that here in the uppermost layer, upper layer application, so we considered different parameters like performance requirement, capacity requirement, data protection requirement, data lifecycle management, followed by there is a virtualization API. Within the storage area network, we can have virtualization engine or appliance along with the physical resources. A virtualization aware application may communicate its requirements to the operating system. So the virtualization API, it will communicate with the it will communicate its requirement to the operating system, virtualization API, which in turn notifies the SAN-based virtualization engine. After that, so this will notify the SAN-based virtualization engine, SAN-based virtualization engine. This configuration puts the application in the control of its supporting data infrastructure. So we have to take the virtualization appliance or engine. It will communicate with the virtualization API, and after that the virtualization API which will communicate with the SAN-based virtualization engine. So the entire configuration puts the application in the control of its supporting storage infrastructure. Virtualization API is an operating system enables upper layer application to communicate requirements to storage virtualization entities in the SAN. So whatever the application API we are using, it's nothing but an operating system itself which enables higher layer application, which enables higher layer applications to communicate its requirement with storage virtualization entities within the SAN. So the API, virtualization API, whatever we are considering, it's just an operating system that enables higher layer application to communicate with the storage virtualization entities. Virtualization awareness facilitates the integration of applications and infrastructure by enabling the application to define its own storage requirement. So you can say that the virtualization awareness which will give the facility that the integration of application or combination of all applications and infrastructure. So that can be done by enabling the application to define its own storage requirement. Virtualization aware applications expand the scope of storage intelligence beyond the SAN. You can say that the virtualization awareness which will provide the facility in order to integrate all the applications, as well as the applications can be expanded So whatever the applications which is located within the virtualization-aware, it can be expanded to scope of storage intelligence beyond the SAN. So in order to get the better scope beyond the SAN, the applications can be expanded.